Hey folks, Quilly18 here, and welcome to another episode of our mostly civilized Hex engine in Unity here, a project for making a Hex-based tile engine, the sort of thing that you would expect to see in sort of 4X games, such as a Civilization, for example. Our last few videos were all from a live stream, where we mostly worked on the map. We also did some camera functions, and I got to give a shout out. We got a couple of contributors over on the GitHub repository that made a couple of little tweaks in here and there to the program. In particular, Chen, I suppose, is probably how I should read your name, Chen18, who did a slight tweak to the camera zoom function and has resulted in something that feels quite a bit smoother. I really enjoy it, so thank you very much for that. And of course, there's plenty of room still for tweaking that. But today, we are going to finally stop messing with the camera and with the terrain generation, and we're going to look at moving a character around. Now, we're going to start off by writing code that directly moves a character from one tile to another tile. But then we're going to incorporate that into a true and proper pathfinding system. So let's go ahead and get started. What I have done is I have grabbed a 3D model from the Open Game Art website. You can go to the source file right over here for information as where to get it. This is, I believe, it's Creative Commons license over here, and you can get all the information about the author and stuff in that source file. But it is a dwarf, is what it is for us. So I'm going to go ahead and drop this dwarf into the world and find you. Where are you? You're right over here. Excellent. Now, we're going to do the standard thing, actually, where what we do is we create an empty and center it, which I really should have done this first, but that's okay. We're going to center this and put the objects inside of that. So this is going to be our unit dot dwarf or something like that. Just some arbitrary name convention. This is the guy that's going to walk around on our map. And by walk around, I mean mostly just slide because he's not animated. I think this figure might be rigged. It's something we could look into in the future, but just animating a character is sort of a standalone thing. Anyway, I'm going to go into this and I'm going to remove the plane at the bottom. Thank you. Also, I have some materials that I have previously set up just to make this look a little bit nicer. Metal armor goes on armor. What else did I call you? I mean, these are the textures, but these are not the materials. What did I assign you to? Cloth mat? Okay, there we go. Cloth over there. Body. There we are. I think, did I miss something? Oh, leather, I think. Dwarf leather goes on leather. There we go. Doesn't he look fancy schmancy? Excellent. Again, I didn't model him or texture him or anything like that. Just bring it into to Unity. There we go. So it is a Blender file, this dwarf here. So we've got our prefab here. He's looking great. We're going to take this unit and we're going to go ahead and drop him in prefab. Now, what I'm going to do is I'm going to hit play because almost certainly he is the wrong size completely. So question number one, where is our map compared to our dwarf? You're there, and now where's our dwarf? Oh, way over there. Oh, the map is way offset because the camera's way offset? Oh, the camera is. Okay, let me just bring the camera over to a 0 point over there. There we go. Now we can see our little dwarf in position. I just want to get him sized to be roughly okay. You know, he's not terrible, to be honest. That is, I mean, it's too big, but not apocalyptically so. He definitely fits in within a hex. I mean, if you're going for a high visibility unit, that wouldn't be too bad. But I think what we're going to do is we're going to scale him out. Let's try by half. And I think now that's probably a lot closer to what we want. So I'm just going to go ahead and copy that. And then I'm going to paste the component values in here to get our scale in our editor, because of course you by default in Unity, changes that you make when things are running do not get carried over. That's okay. We'll go ahead and apply these changes. So there we go. So now we got a nice little prefab unit to move around here. So we're obviously going to need some sort of code to, well, I guess we're going to instantiate this dwarf somewhere and then to move him around. One of the things I want to do is I just want to make a quick note about a good tile that we want to start this dwarf at, right? If we, again, just so that we can get our inspector in the right kind of place, like maybe right over here. This will give us some work. So what are you? 3615. Okay, so we're going to assume in our hex map continent here. Embiggen things. Thank you very much. Generate map. Actually, I guess just the base hex map is going to be okay. No, it's fine. We'll put it here. I guess. Oh, actually, in our base hex map, we're going to want some sort of function here. I don't know if it should be public or private. We'll just do it public for now. We're going to do something like spawn unit at. And it's going to take something like a... I don't know about a game object prefab. I mean, it might need that. But it's going to need an int q, int r of some kind over here. And spawn unit at is going to spawn it... Is this the generate map function? It is. We're going to say, so, some sort of prefab, and we're going to spawn it at, what was it, 3615? Somewhere around there will be on that continent anyway. So, almost certainly we're going to want, let me organize this, put the hex map over here. Almost certainly we're going to want a proper kind of library or something like that to store our characters in. Something that's flexible. Again, just like here, we're not necessarily going to want to hard code this in the future. But for now, we're going to have something like this, and this is going to be our unit dwarf prefab. Just so that we know something to spawn in a particular location. Now, this isn't actually going to be enough / correct, but let's just go ahead and get this done first. Make sure we're happy with the basic placement and see how it goes. So we're going to go ahead and we need to get the position of this tile, right? So first of all, obviously we're going to get hex at QR. And with this, then we want to get the position. The position based on... Oh, we can just find the game object for that. That's what we want. So we want something like the hex to game object map, where we pass in a hex, which is this one, and we're going to get the transform. Actually, we'll just keep a copy of the hex for a moment. This game object, my hex is equal to this. So this is the hex where this unit is going to spawn in. Okay? And in fact, what we're going to do is we're going to attach this unit as a child of the hex game object, just to keep, again, our hierarchy really nice and organized. So we're going to instantiate this prefab at my hex. Well, we need, just to say, we're going to have my hex.transform.position. I guess the rotation is going to be just identity, and we'll set the parent to myhex.transform over like this. So this is the world position we're going to be spawning at, and it's going to be a child of there. So now if we run this, we should get a dwarf that spawns in a particular position. I'm going to change the hex prefab to re-enable the mesh renderer for our text label so that we can see the position labels once more. So, there it is, unit dwarf. Oh, my bad. This is the one that's in there. Hex map needs to be told what the unit prefab is. There we are. Unit dwarf clone, perfect. Okay. And you have spawned in the right place. I think just to make my life a little simpler, what I'm going to go ahead and do is I'm going to rotate this thing 100 degrees on the y-axis, just so that it faces the sort of expected camera position. So if we hunt around here for 3615, you've got it there. And what's quite interesting is if we were to continue to pan over here, the dwarf, because it's a child of the tile, will automatically correctly loop around for the camera. But there's our little dwarf right over there, and doesn't even look fancy. Oh, you can see the camera come down in the preview mode. All right, so that's phase number 1. But the thing is, this is not the correct information, or this is not sufficient information for us to track this unit. Obviously, these units are going to need information about themselves, right? They're going to need, hit points, speed, are they cavalry versus melee, have they been promoted, that sort of thing. These units are going to need data about them. And then we once again come to the question of, do we add this as a component to the game object, or do we make a pure data class in C# just called unit, and then keep a map between the two? And for games like this, like, the thing is, the simpler the game is, and also the more sort of innately physical the game is, right? If it's really truly acting in 3D space, then it really makes sense for these components to just be part of the game object. But the more complicated the game is, and the more sort of strategic and unphysical something is, the more it starts to make sense to keep things as a separate data class. Like, we're going to be really happy that the hex data over here is not a game object component. Because again, one of the really powerful things about this is it means that you don't need the game object to exist for this hex to exist, right? If we got into a situation where we were, say, culling the hexes such that we literally destroyed game objects for anything that weren't on camera, and as the camera moved around, maybe we recreated things or something like that. That's probably not a good optimization for a project, but it's conceivable. Well, the advantage of this is, even if the game object were destroyed to, clean up some data, the hex object still remains as part of our hex map information, which means we can still reference it, we can still work on it, we can use it in the pathfinding system, which becomes very handy. These are not necessarily lighter weight objects for us to send to the, say, the pathfinding engine than, a component is or anything like that, but it can help separate the functions. Anyway, as such, I kind of feel that I might want to do a similar thing with the unit. Basically, the trend that I like to do for games like this, the same sort of thing we did in Project Porcupine, is the idea that the game components, the things that are attached to game objects, are simply there for the sort of user interface layer, right? Things that handle animation, sound, etc., etc., etc. Whereas the actual data over here is responsible simply for tracking the in-game information. That may be an unnecessary layer of whatever, but it's not a bad approach. That being said, I am tempted for the units to do it as a game component, because the units class is actually going to be a bit simpler. But we'll keep going with the pattern that we've got going on right now. That kind of separation of data versus display, right? And again, a big part of that is my web developer background, that sort of MVC infrastructure, model view controller separation, where model is the code, that's the data, view is the thing you show your user, and the controller is the sort of glue layer in between. In this case, the hex map is basically going to act as the controller to our models, which is the hex and now the unit class, which I'm about to create, and then the game objects. And the game objects will have components on them. I mean, maybe the hexes won't, but the units definitely will, because they'll do their idle animations, and their component will also be responsible for smoothly animating the unit as it goes from one hex to another, whereas in code, it's going to happen kind of instantly. So we're going to create a data class called unit, which I'm trying to drop down here. There we go. I don't know why I couldn't just drop it down there. That's very awkward sometimes, that little interface. Loading. Yes, maybe. Come on. Try it again. You can do it. There we go. All right. So, again, this is just going to be a default class. And in a very substantial way, this could probably just be a struct, which would be more lightweight. But what we're going to have is we're going to have a public hex. So this is the hex I'm standing in. And probably, this should probably be something like a public get and a protected or even private set. Okay, so this is going to be a property. The idea being, we don't want something outside of the unit putting us in a different hex. Instead, we're almost certainly going to want a function called setHex or something like that. Now, what you could do, right, if you needed to do anything else, what you could do is just make the set, like, instead of just having the blank one, you could still have it be public, but put some logic and code in there. But there's a very good chance that whatever public void set hex is going to do, there's a very good chance that it's going to have side effects. It's going to trigger something else. And you don't want to be in a position where doing something like hex equals this has weird side effects that are unexpected, right? Maybe a sanity check, maybe something like that, but maybe no unexpected results. Whereas an explicit function like this is a little bit more, you can sort of like wrap it around your head that something funny might happen. At least by convention, at least for me, it helps keep things going on. I mean, for now, it's just going to be doing this, but I'm not sure if that's always going to be the case, right? So the idea is a unit stands in a hex. A hex could probably have multiple units. I mean, you can have one unit per hex or not. You know, that could be something that you could arrange and organize. But it's very easy to imagine something like we have a just a protected array of units, or list probably. List, unit, units in... Well, just probably units is fine, actually. And then in our constructor, we make sure to instantiate units is equal to new list of units. Actually, I'm not even sure we want to do it in a constructor, because we're going to be doing some things that will be sort of generating some temporary hexes. So we kind of want to avoid doing a little overhead stuff over here, which is fine. But what we can have in here is something like a public void add unit. So unit like this. And then in here you say if units equals null. I mean, yes, you have to do this check every single time add unit runs, but it's a very quick check, and add unit doesn't happen that often. So we'll make sure to instantiate the array there. Otherwise, we go units.add unit. Should sort of be a set, actually, is what I'm thinking, instead of a list. So the difference between a it's hash set. I guess hash set is fine. Is that this is really unique. Now I'm trying to remember hash set, because you can have a list and you can add the exact same object to a list multiple times, and I think it will just be in the list multiple times because it's a reference thing. But I think hash set will throw an exception if there's a duplicate. I might be wrong. Oh, it'll return a true or false. So true if the element was added. It will return false if the element is already present. So it won't throw an exception, but what's important is that it won't add a duplicate. Whereas if I go generic list, sorry, I'm just double checking here, because it's kind of a handy dandy thing to note. If you call add, adds an object to the end of the list. Lists are also ordered. Hash sets are not, which might be a thing. I don't think it matters. Yeah, the list add doesn't even return anything. So we don't actually care about the return value here. We don't actually care if this returns false because unit was already in the list. What matters is that the same unit won't be in the list twice, because that would be weird and not make any sense. And then you can go public void remove unit. And then we get an interesting question here. Right? So unit. So we can just call units.remove unit. But the question becomes, what happens? Should we do anything if units does not contain unit? Or if units was null? Right? Because we could check for that. We could check to see if this list already contains units and throw up some sort of error, because clearly something's got a little funny somewhere. But I don't think it actually represents a problem. I think what we do want to do is, make sure to catch the case of if units, as long as units is not equal to null, then we go ahead and try this. And then I guess the question becomes at that point, just out of curiosity, does hash set return or throw an error if you try to remove something that's not in there? I don't know if it does. It just returns true or false to let you know if it actually removes something or not, but doesn't throw an exception. So if you try to remove a unit that's not in the list, you're not going to get any sort of error whatsoever. It's just going to silently try and then be like, oh, it wasn't in here anyway, so that's going to be fine. And then we probably want something like public unit array units. And this is just going to return units dot to array. I can't do a to array. So you can get a list sent to an array, but apparently not this. But I think if we do system.link, I think this will add support for these collections. There we go. To return this. The only reason I'm doing this is because I don't want to return the hash set itself, because then someone outside of our class could modify that hash set. But now we have the ability to add units, remove units, and get the list of units in this array, in this hex over here. So the idea is when we set the hex, what we should actually do is something like if hex not equals null. If we were already in a hex, then we can say hex.remove unit this, hex dot add unit this. There we go. Oops, capital. There we go. If we had a hex before, then we remove ourselves, then we add ourselves to this new thing over there. So now you can see here that set hex has some side effects over here that I think that having it be in the set operator here, the setter, I think it's kind of awkward, and I've run into problems where I've shot myself in the foot doing that before. So it's just sort of a convention I developed. Although it is a little bit weird to have both like accessor functions and this, but I think that's going to be okay. What's next? Well, clearly the unit will have some stats. These I'm going to make like just fully public for now because it's going to be fine, and we can figure out some other solution later on. So we're going to have a string called name. That looks weird. Are there two n's in unnamed? I'm feeling... Yes, okay. Like, hold on. Something's not right here. So, string name, then public, int hit points, which normally are 100, public int strength, which this unit has a strength of 8, for whatever that means. All right. Well, you know, some dummy data in there that we can fiddle around. Oh, some actually important stuff, though, is probably something like movement. So this unit can move 2 steps on a turn, and maybe movement remaining is equal to 2. Something like that. So again, mostly, like, with unit doing so little, I mean, unless we end up with a constructor or whatever, this could be a struct, which does have a little bit less overhead, and we could consider that in the future, but let's just make it a class for now. So we got some sort of dummy unit information over here, and that's going to be okay. So in fact, for our hexes over here, what we probably are going to want is some sort of system that defines our various units. And then links it to a prefab. Actually, I'm almost wondering, like, do we want to be able to define it here? This actually might be a one use case for like a scriptable object for us to define our various units. I don't know. I don't know how we want to be able to input this. I think what I'm going to do right now is I'm just going to hard code in some stuff. I'm just going to assume like the default one is just going to be called the dwarf. That's going to be it. So we're going to make a slight change over here for spawn unit at. What are we going to do? We're going to, in our startup, we're going to set up some sort of, it's fine. Spawn unit at, so it's going to require a unit now. Over here, a unit and the prefab for it, although there'll probably be some sort of other map that goes from one to the other later, but that's going to be okay. So we're going to just make a dummy unit equals new unit like this, and so we'll pass that over here. But probably this will need some sort of master list of units, like all the unit types, right? So imagine you're reading in from a JSON file or an XML file or something like that. It's got a description of every unit. You know, dwarf costs 10 to build. These are its stats. We've got mounted knight. This one costs 20 to build. Here are its stats, etc., etc., etc. So we have something that reads that configuration file, creates a bunch of these unit objects in some sort of master list that also links up with, and this is the correct prefab for this model over here, so that when you spawn a unit, here's the matching prefab. So we're just going to hard code those in now, and it might actually be outside of the scope of what we're going to try to do here to do the full sort of construction array. We'll see. It'll depend on how sophisticated we want to get our little like city interface to go. But the important thing is to get something working right now. So now we got a unit and a prefab, and what we're going to do is, just like we have the hexes list and the hex game object map, I think what we're going to do is keep track of the same thing over here, where we have all of our units, because most likely what we're going to want to do is every turn of the game engine, we're going to want to call something on unit, something like, you know, public void do turn, or something like that, right? Like, you know, do queued move, or something. I don't know, like something like that is likely to happen. We're going to want to loop around. Then we're going to have a dictionary here that maps a unit, and it's the 1, 2, 3 unit to game object map over here. Yeah. So just let it remember what these things are called. So down here, we're going to say if units is equal to null, then we need to make sure that, oh, okay, it's not, units will not be a two-dimensional array. In fact, what this is going to be is a list. Yeah, a list of all units. List, unit, boom. Or again, a hash set, perhaps. Because you're not supposed to have two copies of the same one. Although, I don't think there's any way that you'd end up with two copies of the same thing over here. So now all of a sudden it's units is equal to new, not this, hash set of units. And we'll also at this time instantiate the calendar. Like that. Or the calendar, the dictionary. You know, the other household object. So then what we're going to do is we're going to create the game object. We've got the hex, we've got the game object. So then we can say units.add unit, and unit to game object map. We will say, so unit is equal to, I guess we need to keep copy this, game object, unit game object is equal to that. So then we've got a mapping of it, so we can always find whatever we need over here. We had a discussion on stream last time, like why use, why do I use the square brackets? You could also do it this way, unit game object. Functionally, at this stage, there's no real difference. You can use this to add a new item to a dictionary. The difference is this variant here will actually, I believe, throw an exception if this key was already present in the dictionary. If there was already a listing in this dictionary that had unit in the as a key, then it would freak out and throw an error. There's no possibility in this particular scenario that's not happening because, I mean, well, I mean, there could be something weird. This might actually be a use case where just on the off chance we happen to feed in the same unit twice in some sort of bizarre way, then maybe this would be a good thing. I don't think it really matters much, but I guess just for symmetry here, we'll use the .add in both lines, but it really doesn't make any difference. Okay, so now we can spawn a unit. It'll spawn at a particular place, get added to this whole database, and we've got the separation between the data over here. And so yeah, again, so things like do turn. This is not anything that involves the animator. Anyway, but yeah. So we've got that, and I guess the next episode, what we are going to do is work out the animator. Let's go ahead and resolve this little error here. Oh yes, hash set. Anything else? No, you're good. If I hit this, we don't get any errors. Nope, and the dwarf spawns at the right place. Okay. And it should have an associated unit data somewhere in there. We could tweak the text shader here to not be see-through. What I should just use is the pro text match, which I think will do that by default. But That's okay. We'll just keep going with this for now. All right. So next episode, we'll get this dwarf moving around. Thanks for watching. See you next time. Hey, I want to say a great big thank you to all the June Patreon supporters and these Mic Check supporters. We've got Yukofin, Eric Sumner, Tiburon, Mighty Mix, Pavel Zdanov, Drazion, Michael McClintock, Aaron Toyson, Craig Mortel, The Not So Evil Engineer, Julien Auger-Lafont, Marius Fieldvold, Speedy Savant, Valiant Cakefiend, Thomas Oberson, Jason Yanity, Stephen Bonnerman, Kale the Quick, and Neil Blakey Milner, and absolutely everyone who watches, shares, favorites, and subscribes to these videos. Thank you so much.